Welcome to Untitled Maths. In this video we're going to have a look at exponential graphs. Now what we mean by an exponential graph is when you've got the variable x as a power. And all exponential graphs have the same general shape, unless you have it as a minus. Now if you remember about minus powers, you might need to recap on that video if you're unsure of those. If a power is a minus, then it's a reciprocal. So, like for example, the 3 to the power of minus 1 would be 1 over 3. 3 to the power of minus 2 would be 1 over 3 squared. And 3 to the minus 3 would be 1 over 3 cubed, so that'd be 1 over 27. That would be 1 over 9. So what you can see quite quickly is that when it's a negative power, the number's going to get very, very small. But what will happen is, as it gets more negative, it'll get smaller and smaller and smaller, but it'll never actually reach 0, so it'll never touch the x-axis. So that's what we call an asymptote, where it gets closer and closer, but never actually touches. When the powers are positive though, 3 to the 1 would be 3. And 3 squared would be 9, and 3 cubed would be 27. So what will happen is the powers will get very, very large, very, very quickly. And you're going to get this sort of curve. So if I'm going to sketch a graph, I'll start very, very small. It'll come up and it'll sort of curve upwards. Should be a bit more of a curve there. And the point where it touches the y-axis is where x is 0. And 3 to the power of 0 is 1. So the coordinates of where it touches the y-axis is 0, 1. And it never touches the x-axis. It just gets closer and closer and closer. In this one, we're going to look at what happens when you multiply the exponential part by a number. So we've got 3 times 2 to the power of x in this question. And it's going to follow the same general structure. It's going to get very, very small at negative powers. It's going to get very larger and larger and larger when you get to positive values of x. All the values are going to be multiplied by 3 though. So when we're sketching this graph, we are going to draw a similar sort of shape. It starts very, very small and it comes up and it curves upwards. And what we need to do is we need to label a point at which it intersects the y-axis. 2 to the power of 0, because anything to the power of 0 is 1, but it's 3 times 2 to the power of 0. So if we do 3 times 1, we get 3. So the point at which it intersects the y-axis is 0, 3. And again, it gets very, very close to the x-axis, but it never actually touches. So that's our answer for that question. And the final one we're going to sketch is going to be y equals 3 to the minus x. So what we've done here is all the positive values are going to be now minus, because it'd be like minus 1, minus 2, minus 3, minus 4. And all the negative values will become positive, because when you have minus 1, that's a double negative, so it's going to be a positive. Or minus 3 would, example, be 3. And what that's going to do is it's going to flip up the values over, so you'll have it'll be getting smaller and smaller on this side. And on this side, it'll be getting larger and larger and larger, because these negative numbers now all make a positive power in this equation. And all the positive numbers make a negative power in this equation. So what we'll get is something like this. It'll start out very, very small, and then it'll sort of curve upwards. Okay? And the point at where it crosses it'll be where 3 is to the power of minus 0. But it doesn't matter if it's 0, it's 0. So it'll be 1. So the point at where it intersects the y-axis is 0, 1. And now we'll have a look at our final question. So this is where they give us 2 points on the curve, and we need to find the values of a times b to the x, because when they're written together like this, it means a multiplied by b to the power of x. And I've been given 2 points. Now, to work out the a value, I'm going to use this first point here, because I know whatever b is, b to the 0 is always going to be 1, because anything to the power of 0 is 1. So the y value at 0, 5 is 5, so it'll be 5 equals a times, well, b to the 0 is 1, so 1, which means that a is equal to 5. Now that I've got a is equal to 5, I can put that into the equation, so I can rewrite it as y equals 5 b to the power of x, and I can use the final equation, which is, well, the y value is 135, so I'll write 135 equals 5 times b cubed. And I'll need to rearrange it, so I'm going to divide both sides by 5 to get rid of the 5 on this side. That'll cancel out. And 135 divided by 5 is equal to 27. So b cubed equals 27. And we know the number that, what is cubed to get 27? Well, that's going to be 3. Or we could, say, cube root both sides. b equals the cube root of 27, which is 3. Therefore, a is 5 and b is 3. And that's how you work out the a and b values for a question like that. Right, thank you for watching. I hope you found that helpful. If you'd like to see more videos, please hit the subscribe button. And for practice questions, please visit my website, www.mitchellmathsandscience.com. The link is in the description.